Yes, now let's start. And now let's give a separable equation. What's the separable equation? And the first order differential equation and means highest order first order derivative. Dy over dx is equal f of x times g of y. And look at the right hand side. Be careful. This one is the product and also product of the first one function of x, the second one function of y. And here dy over dx and means y is a function, y depends on x. It's okay. Independent variable x. Right hand side contains two function and the such that and the right hand side should be product of the two function. It's okay. So it is possible to separate these function. It's okay. Or maybe we can use this form mx dx and y dy is 0. And be careful here, the coefficient of dy is a function of y, coefficient of dx is a function of x. Be careful. It's okay. The same type. It's okay. Is equal 0. And so, and if our equation in this form is okay, in this form, and this one is the first order differential equation, yes, and also if our equation in this form or this form and is called the separable equation, so it's okay, of order 1. And what is the and how to find the solution? And the general solution of this differential equation, separate the parts and this take to this one, separate parts, and we can write dy over g of y is equal, yes, dx over f of x. It is possible to separate, take this one here, and so we obtain this one. This one is okay. So how to solve this equation and integrating both sides, so we obtain this one. It's okay. Or take this one, integrating both, if our equation in this form, second form, and integrating both sides, so we obtain sum of the two integral is equal, integral of the 0 is c, constant. So, and this one gives the general solution. And here c, of course, arbitrary constant. It's okay. And so to understand this type equation, how to find the general solution of the separable equation, let's give an example. It's okay. Let's give an example. First of all, and look at this one. It's okay. This one. Our aim is to get the solution. We claim that this one is the general solution of our differential equation. It's okay. But here solution is not in this form. In this form, it's okay. Y of x in this form. So if we have and this one is explicit. This one is implicit solution. It's okay. Implicit. So let's get this solution, the general solution of this differential equation. First of all, identify this differential equation and contains y prime only. It's okay, highest derivative. So first order differential equation. And separable, yes, separable, because look at the right hand side. This one and this one is this one is the product of the two function of x, function of y. It's okay. So separable equation, this one. So, and separate the parts and write here and write this one. So we obtain this one and we can write this one. We obtain this form. What's the form? M times dx plus n times dy. It's okay. So how to get solution? How to get solution? Integrating both sides, we obtain the solution. It's okay. So this one, integral of 1 minus y squared minus x squared. This one gives c. It's okay. So this one gives, and this one y cube over 3, and this one x cube over 3. So we obtain the solution of this one. It's okay. So but and it will be better to rewrite and our solution. It's okay. our solution. Our aim is to get the under this one. It's okay, this one. And this one, it is enough, but to get the our result, multiply by 3, so we obtain this one. And 3 times C, and it can be written C, abuse of notation, and define the bold C is 3C. It's okay? So we obtained our solution, abuse of notation. It's okay? Any question? No question? Okay. Let's give one more example. dy over dx, our differential equation, and also we one and the initial condition, first order differential equation. So this one is contains initial condition. This one is called initial value problem, and to solve the initial value problem. And the first step, identify this differential equation and solve this differential equation. So we get the general solution, and then choose the one solution here, and this such that these solutions satisfy our initial condition, and then we obtain unique solution of the initial value problem. It's okay. So, and take our differential equation and rewrite. This one is a function of x. This one is a function of y. Separable equation. So, and separate this equation and integrating both sides. So we obtain this one. Is the general solution. Is okay. General solution. And our aim is to get the solution of the initial value problem. So choose the solution such that y of 0 should be -1. It's okay. Substitute here. X is 0, y is -1, and find the value of c. C is 3. It's okay. C is 3. And so right here C is 3, and we get the this one. It's okay. Look at the R and the problem. We claim that this one is the solution. This one is the unique solution of our initial value problem. Let's come back. Y is 1 minus square root. It's okay. Let's come back. This one. It's okay. So, and rewrite and this side is equal, yes, plus -1 and -1, and because this one is plus 0, add the 1 and -1, and then we obtain and the left side y minus 1 square, and this one and the -1, and here plus 1 and the 4. So, and we obtain this one is equal this one. It's okay. So our aim solve for y, and to get y and take the square root both sides. So we obtain y minus 1 plus and minus square root this one. But we know that our problem is the initial value problem. Initial value problem has a unique solution. Unique solution means yes, but here we obtain two solutions. It's okay. Two solutions. Look at our result, y minus 1 this one. So we obtain y is 1 plus minus this one. We obtain two solutions. But our aim is to get one solution, unique solution, because should be unique solution. So, and which one it is true? But we claim that here at the beginning, y is 1 minus square root, not plus. It's okay? So, how to find this one, and look at the initial condition, y0 should be -1. Let's come back here. This one, it is true. This one is true because what's the reason? Because y0 should be -1. And here write the x is 0, 0, 0, 0, and 4, and we obtain 1 minus 2, we obtain -1, satisfied. If take the plus, 1 plus this one, x cubed plus 2x squared plus 2x plus 4, write the 0 and the 0 and here, and this one is 0, 0, 0, and so we obtain 1 plus 2, 3. Not satisfied our initial condition. So, and this one not solution. It's okay. Any question? So R and solution should be 1 minus square root, not plus. It's okay. Any question here? I think it is clear. It's okay, no question, I hope. So let's give one more example. It's okay. And this one is initial value problem. It's okay. Solve the initial value problem. We claim that this one is a solution. It's okay. So look at this one, first order differential equation and also separable equation. So separate parts. We obtain two parts. So and rewrite, we obtain this one. Integrating both sides. So we obtain this one. It's okay. dy and 4 and 4y. Y cube, y to the 4 over 4. And the dx for x, 2x squared minus x cube minus x to the 4 over 4 plus integration constant c. It's okay. This one is the solution, and the general solution. But here we have one initial condition, satisfy this one, and the substitute x is 0, y is 1 here. It's okay. So we obtain value of c. C is, yes, 17. It's okay. And then substitute here value of c, and we obtain this one. It's okay. So we obtain our solution. Any question about the solution? Okay, no question. Now let's give one remark here. It's okay. And this one, it is important. It's okay. And such equation, if our equation in this form, what's the form? And the first order differential equation here, dy over dx is equal f of y over x. F of y over x. It's okay. It's a function of y over x. And then if our equation in this form and this and the, if our equation in this form and this equation transform into the separable equation always. It's okay. Always we got the separable equation and from the R equation. And then, so we know that how to solve the separable equation. And then we obtain the solution of the separable equation. And then let's come back to our differential equation. So we obtain the solution of the R differential equation. It's okay. How to apply this one? It's okay. Let's see that. And this, if our equation in this form, and this form means dy over dx, f of y over x, and this equation is called the homogeneous equation. It's okay, homogeneous equation. So, and they change the variable here, y over x, and the v is y over x. Assume that. So, what's the y? And the solve for y. Y is v x. Our aim is use this substitution. So our differential equation, new differential equation, but new differential equation should be separable equation. We claim that. It's okay. If our equation in this form, it's okay. Using this substitution, so we obtain separable equation and then solve this and the equation. It's okay. So let's see that if and use this substitution, y is vx, but here our differential equation contains and the first derivative. It's okay. So you have to compute the first derivative. It's okay. So what is this one? Our aim is to find this one. It's okay because we can use and this substitution. We have to compute and this one. It's okay, dy over dx, and means take the derivative with respect to y is this one. Take the derivative with respect to x, and take this one dy over dx, and So this one is the product of the and the two and the this one, and use this one u prime v plus u times v prime. Use this rule. It's okay. So we obtain dv over derivative of the first one, dv over dx times the second one, plus first one times the derivative of the second one, d over dx. This one is 1. It's okay. So we obtain dy over dx is equal x times dv over dx plus v. It's okay. So and rewrite this one, and also we know that dy over dx, look at our equation, dy over dx f of v, f of dy over dx, use this substitution, is equal f of v. It's okay. And the substitute here, it's okay, right? This one is f of v is equal x dv over dx minus plus v. And then we obtain f of v minus v is equal x dv over dx. And this one, yes, we obtain separable equation. It's okay. So separate parts. So we obtain here dv over this one, dx over x. We obtain this one. And new and equation, separable equation in x and v. So we know how to solve. It's okay. And then we obtain, use the back substitution, we obtain the solution of the our differential equation. Okay. And let's see that this method is okay, how to apply. And let's give an example. This one is a theory of this method. It's okay if our equation is this form using this substitution. So, and the substitute here is okay, and substitute dy over dx and also here. And then we obtain this differential equation. Differential equation is separable equation. It's okay. And also we know the how to solve the separable equation, and then we obtain the solution. Yes. Let's give an example to understand the homogeneous equation, how to solve the homogeneous equation. It's okay. Look at this differential equation, dy over dx, this one. And first of all, identify this equation. This one is the first order differential equation. Yes, first order differential equation because contains and the highest derivative y prime. And so this one is separable equation, and this one not contain only y, only x, not separable, and in this form. It's okay. So first order differential equation, but be careful and look at the right hand side. Right hand side is a function of y over x or not. Yes, rewrite under this one, and this one is can be written in this form. So right hand side is a function of y over x. Yes. And how to get this one? It is easy to see that how to get this one, because rewrite under this one is equal y minus 4x over x minus y over x, and this one y over x minus 4, and we obtain this one. It's okay. It is easy to see that. So we obtain this one. So we know that, and use this substitution. This one is v, this one is v. It's okay. So use the y is v times x. We know, use the product rule, differentiate with respect to x derivative, and so we obtain this one. And substitute here, take this one. Take this one, dy over dx, this one. It's okay, is equal, and also this one is equal. So we obtain x dv over dx v is v minus 4 1 minus v. So look at the new differential equation, this one, it's okay, and rewrite and this differential equation. So take this one, it's okay. So we obtain this one is equal this one, and separable equation. Separate parts and take the integral, it's okay, integrating both sides. So we obtain our solution. But you have to use the method partial fraction. We know from calculus 1, it's okay. So this one is ln x, but this one we don't know, and what's this integral. Use the method partial fractions, it's okay. And so what does it mean? 1 minus v over v square minus 4, and this one is 1 minus v over v minus 2, v plus 2, and this one can be written in this form, v minus 2 plus b, v plus 2. Integration partial fractions, and find the a and b. We claim that a is minus 3 over 4, b is minus 1 over 4. It's okay. And so, and this integral is equal integral of this one and this one. So we obtain ln 1 plus 2, ln 1 minus 2. So, and what's this one? Use the property, and this one gives product, and but first of all, right, I think this one is equal minus 1 over 4 times ln v plus 2 and plus ln v minus 2 cube, this one. So, and this one gives ln a plus ln b is ln a times b. So we obtain this one. And what's this part? This one is ln x multiply minus 1 over 4, and this one. And so, and this integral plus constant plus c, but evaporate, and this one is this integral gives ln x plus c. But I think it will be better and take not c, ln c, write ln c. It will be better. It's okay for constant c. And then this one is, and the power here, and ln a plus ln b is equal ln a times b, this one. So, and we obtain this equation. It's okay, rewrite, and then we obtain the result. Any question? Any question about the solution? This one is homogeneous equation, and then we obtain and use this substitution. We obtain the separable equation. Yes, this one is separable equation. We know how to separate, how to solve this equation, integrating both sides. So take the integral. You have to use the partial fraction method here, of course, and the for and this integral. And then we obtain this one, and the rewrite, we obtain the solution. It's okay. So now, and let's stop here, and because and the next and the day, and we will give the exact equation and integrating factors, and if our equation in this form, it's okay, mu plus nu dy over dx, or this one, it's okay. Look at this one, not separable, because this one is a function of x only. This one is not function of y. If this one is mu x, this one is nu y, is a separable equation. This one is first order differential equation because y prime highest derivative, first order. But And this one is not linear because the coefficient of dy over dx is not contain only and the x, y, not linear, and not separable because the coefficient not m of x, coefficient of y not is a function of y, not separable. So this one is other type of the first order differential equation. And this one is called the exact equation. So what's the condition? Let's give the condition, and also we will give the method how to solve the exact equation. It's okay. Any question? Let's stop here. Any question about solution of the concept or about this and the lecture?